Hello guys, welcome to my YouTube channel. Today we are going to be doing another Python project. But if you have been watching my videos and you have not subscribed to my channel, please kindly do, please, so that you can follow up on my project. And if you have any question regarding my project and you want to ask, you can use the comment section. Anything you comment in this comment section, I will definitely respond. If I see that it's a question that I need to answer, I'm going to definitely answer that question. So if you have any question regarding my project, you can comment in the comment section and we're going to attend to it. So let's get started with our today's project. As I've said, please don't forget to subscribe to my YouTube channel. Let's get started. So today we're going to be writing a Python code that will help us detect if a particular number is a prime number or not. So using the primality test. So it's going to help us test if a particular number is a prime number or it's not a prime number. So let's get started. First, we need to define. So we need to define what a prime number is, the conditions, for a number to be a prime number. And before we really define, firstly I want to ask us, what is a prime number? So a prime number is a whole number that is greater than 1 and that cannot be exactly divided by any whole number other than itself and 1. So it's a number that is greater than 1 in one hand and cannot be divided by any whole number other than itself and 1. So we're going to put all this in our definition so that we'll be able to get the right answer. So I'll define first. Def is, so define that. So we're going to say if n less or equals to 1, now this particular code here is saying something. It's saying that if the number is less than or equals to 1, it's not a prime number. You understand? So we need to put 1 here. So definitely it's not a prime number. So we're going to tell the system to return false. Return false. So let's go to the second code. We're going to say elif. So now we know that 2 and 3 are prime numbers, and so definitely it's true. So we're going to include it in our set of rules that we are defining. So we're going to say elif n less or equals to 3, and then we say if the number is less or equals to 3, and I've defined that if the number is less or equals to 1, it's false. So we're now saying the number is less or equals to 3, which includes 2 and 3, then we're saying it should return true. Return true. So what else again? We're going to use the elif statement. Elif. Now what are we defining? We're saying that if the number is divisible by 2 or 3, it's not a prime number. So the function should return false now. So if the number is divisible by 2 or 3, it's not a prime number, so the number should return false. So I'm going to put it into statements. I say by 2 or 3 So we told you to return what? False. Return false. Yes. So that's settled. What else again? Now we're going to give some certain conditions to be able to accommodate more information. So we are going to say I equals 5. I equals 5. And we're going to say now this I is like a variable. So we are saying that we are initializing the variable I to 5 because we already checked its divisibility by 2 and 3 in the earlier condition. So we start from 5 because all primes greater than 3 can be expressed in the form 6k plus or minus 1. So we are going to say if I is equals to 5, and then we're going to now use the y statement. We're going to use y I multiplied by I should be less than or equals to n. Now we're using the y statement, so this is like a continuous, it's like a loop continuous, like a continuous loop until the square of I exceeds n. This is because n is not a prime number and has a divisor greater than its square root. Then it must also have a divisor smaller than or equals to its square root. By checking the divisibility up to the square root of n, we can efficiently determine if n is a prime or not. So that's why we're using this. So we are saying that if n if n I equals to 0 or n I plus 2 is equals to 0. So now this statement in particular is within the loop. We are checking whether n is divisible by either I or I plus 2. This is based on the observation that among numbers that are not multiples of 2 or 3, prime numbers can be found in pairs of numbers that differs by 6. For example, 5, 7, 11, 13, 17, and 19. By checking the divisibility for I and I plus 2, we can skip over multiples of 2 and 3 in search for the divisor of n. So that's what we're trying to do here. So from here we can now determine if that particular number is prime or not. So from here we know that it's going to be false. It is false. So it should return false. Now we need to add one more code also to be able to capture all that will help us dictate if a number is a prime number or not. So we have said that this one is within loop. This to check maybe n is divisible by either I or I plus 2. And this what we're going to, the last code we're going to use. We're going to use I plus equals to 6, which is the increment of I by 6. These steps allows us to consider only numbers that are not multiples of 2 or 3, as mentioned earlier. So we increment by 6 to move from one pair to a potential prime number. which we are using what we call the 6k minus 1 and 6k plus 1 to the next pair. So this is what this particular place is trying to do. So we are going to use I plus equals to 6. It should return true. Return true. Then what are we doing next? Now we are saying if we're not giving what we should come, so if the number what we show on the screen, if the number equals to the input, so on the screen we're going to say enter a number, so that will be our input enter a number, to check if it's a prime number, if it's prime. To check if it's prime, then we close the bracket. So you're going to say if the number is prime, if the number is prime, print number is a prime. So is a prime number. That's for if the number is prime after considering all the conditions that have been placed. We can now say else print number is not a prime number. Okay. After we have completed the code, so I think what we basically did there is very simple. We use the prime, we set some rules that will help us determine if the number is prime or not. So firstly, we said that if the number is less than or equals to 1, it's not a prime number, so the function should return false. We also said that if the number is 2 or 3, it's a prime number, so the function should return true. We also said that if the number is divisible by 2 or 3, it's not prime, so it should return false. We also set a loop to check for the divisibility of numbers greater than 3. We said if I is up to 5, if we initialize the variable I to 5, we check for the divisibility by 2 and 3 in the earlier conditions. I've already said those ones. We can now start from 5 because all primes greater than 3 can be expressed in the form 6k plus or minus 1. So we use the while statement, I multiplied by I less than or equals to n. So this loop continues until the square of I exceeds n. And this is because if n is not a prime number and has a divisor greater than its square root, then it must also have a divisor smaller than or equals to its square root. So by checking for the divisibility up to the square root of n, we can determine if n is a prime number or not. And so we say for that, if the number is a prime number, by after we have checked whether n is either divisible by I or I plus 2, if it's a prime, if we check if it's a prime number, we return true. If it's not a prime number, we return false. So if it doesn't meet this condition in this particular case, it's going to return false. So we use a statement and increment where we say I plus or minus I plus equals to 6. In this case, this is a particular step that allows us to consider only numbers that are not multiples of 2 and 3, as mentioned earlier. So we do an increment by 6 to move from one pair of potential prime numbers to the next pair of another potential prime numbers. So we'll use 6k minus 1 or 6k plus 1, and that's what we did in this case. And so it's time for us to run our code. Let's see if it's going to work or if it's going to be right. So firstly, we encountered our first error as usual, and it's in line 15. Line 15, what went wrong with line 15? Let's go through. We said the number is equals to input, enter a number to check if it's prime. Yes, this is our error is. It should be this, yes. So let's run it again. Okay, we have an error in 15. I think we corrected the error. Let's run it again. Input. Seeing this problem with the input. Okay, I think I use capital. Let's make it small so we can see if it's going to run properly this time around. Okay, now it's running properly. Now it says you should enter any number. Let's start with 1. So 1 is not a prime number. So 1 is not a prime number. Let's say 2. 2 is a prime number. That's good. Let's say 3. 3 is a prime number. That's good. Let's see 4. 4 is not a prime number. Wow. Let's see 5. 5 should be a prime number. Okay, that's good. Let's see 6. 6 is not a prime number. Let's see 7. 7 is a prime number. Let's see 11. 11 is a prime number. Let's see 101. It's a prime number. Let's see 177. It's 177 is not a prime number. Let's see 179. Let's see 179 is a prime number. Okay. So we've tried our code. It's working fine. It's working well. Please don't forget to subscribe to my YouTube channel if you have not. And yes, this is it. So probably in our next video we'll be looking for how to expand this code, probably to see if whenever we put any number it will tell us if it's an odd, even, or prime. That'll be a bit complicated, but not too complicated. We're going to attempt it. So please and please like my video if you have not, and if you find it helpful, please do share our video. Thank you very much for watching.